So first thing I'm going to do, you are going to turn those in tomorrow, yes. And we've gone through every single problem, so even if you weren't here, you should be able to get into Canvas, and it's in Canvas. You should be able to get every single problem. First thing we're going to do is we're going to answer questions B, C, D, and E, and then we'll do these two graphs. So first thing I want to do is identify which one of these is the parent. They tell me right here, the parent function. And then over here, I've got my transformation. When I describe the transformations from the parent, I will only describe things that are different from the parent. What is the base of the parent function? 2. When you go and you look at the transformed function, first of all, how do I identify the base when there's a whole bunch of stuff going on? Whatever has an exponent on it. Which piece over here has the exponent on it? 2. So this is the base. Is the base of the transformation different than the base of the parent? Is the base of the transformation different from the base of the parent?
No.
It's the same base. Base of 2 right here, base of 2 right here. I'm only describing things that are different from the parent. So since they have the same base, I do not describe any transformations there. So far, so good? Also, the base is not A, it's not H, it's not K. What is my A value on the transformed function? Sorry, I thought I heard something, but I couldn't hear it clearly. 3, yes. Our A value is 3. I'm going to circle that just a little bit differently because I don't want to cover up that little dot there. What does this little dot mean? Multiplication. If you multiply something by 3, does it get bigger, smaller, or stay the same? Bigger. So this is going to be a vertical stretch. So vertically stretched. And just like if you were going to tell me left, right, up, and down, you have to tell me by how much. Vertically stretched by, what was that A value again? 3. Vertically stretched by 3. I knew that I had to describe that here because here my A value is 3. What's the A value of the parent? 1. There is no A value there. It's a 1. So this is something that's different from the parent. Anytime I see something that's different, I have to describe it. So here, A is 1. Does my transformed function have an H value? Yes. What is the H value on my transformed function? -4. Here I see +4, but remember that's showing me the opposite of H. So H is actually -4. Yes, so we're going to go left 4. Why down 3?
Because 3 is negative.
If 3 is negative, it comes at the end. This is our K value.
And it goes up and down.
K sends things up and down, yes. So this is going to go down 3. This H value I don't see over here at the parent, so that was something different. That's how I knew I had to describe it. Same thing with K. There wasn't any plus or minus. There was no K value over here. Something different, I need to describe it. Since we know our k value is -3, what else do I know here? Horizontal asymptote. What is my horizontal asymptote? Y equals -3. Your horizontal asymptote is always going to be y equals k. So far, so good? All right. Whatever k is what that's going to be. Let's do our domain and range, and then we'll do our graph. Anytime I'm looking at exponential functions, base with an exponent, base with an exponent, my domain is going to be the same for all of them, no matter what the base is, no matter what a, h, or k is. What is the domain for all of these exponential functions? All real numbers. You can write that one of two different ways. You can write all real numbers like this, -infinity to +infinity, or you can write all real numbers with that weird looking R symbol. For the range, we've talked about ways that we can write the range even when we can't see the graph. If A is positive, then my range will be k to infinity. And if A is negative, then my range will be -infinity to k. Jaden, you said that means it's going to be -3 to infinity. Tell me how you know.
That's my question. Is it because on the y-axis, I didn't think it's because the y-axis it stops at 3 since k equals -3, and it wouldn't go any lower.
So how do I make a decision between this one and this one?
Oh, because a is positive.
A is positive. A is a positive what?
3.
+3. So we know we're looking at this situation right here. But then the rest of your explanation was not wrong. The lowest it's ever going to go is -3. And because A is positive, it goes up from there. So this would be -3 to infinity. So far, so good? All right. I'm taking the time to go very carefully through this problem, and we're going to go very carefully through the next problem, because historically on Algebra 2 tests, graphing problems like these are worth big points, because we're answering a lot of different things here. You've described the transformation, told me the domain and range, told me the horizontal asymptote, and now we're going to graph both of those pieces. All right, so down here with the tables, I like to connect my tables together. X and Y on the outsides here are for the parent. We get to pick our x's. That's what this domain of -infinity to +infinity means. It means we get to choose any numbers we want to for our x values. I have 5 favorites that I like to choose because they're small numbers and they're easy for me to work with. -2, -1, 0, 1, and 2. Yes. To get the y values on this side, I look at this parent function up here. What was the base on the parent function? 2 to the power of whatever x is. So down this column, I'm going to have 2 to the power of whatever the x is right there. So this first one will be 2 to the -2. The next one down will be 2 to the power of what? -1. And then it's going to be 2 to the power of 0. 2 to the power of 1. Yes, ma'am. Yes. We're choosing 2 because that's what my parent function base is, and then the exponents are changing based on whatever the x value is right there. So because the x value is a negative 2 right here, that's my exponent. Here, my x value is negative 1, so that's my exponent. Everybody understand where I'm getting those things from? All right. Let's start at the bottom, because I know 2 squared. What is 2 squared? 4. So I have an ordered pair. I have a point at 2, 4. Right here. What is 2 to the first power? What is 2 to the first? 2. 2 to the first power is 2. So I have an ordered pair. I have a point at 1, 2. Oops, I put that first point in the wrong spot. There we go. What is anything to the power of 0? 1. Lauren, what's your question, dear? Yeah, 2 to the second power equals 4. And so I put a point at 2, 4.
Oh, okay.
Mm-hmm. 2 to the first power equals 2, so I put a point at 1, 2.
Oh, okay.
2 to the 0 power equals 1, so I have a point at 0, 1, and I'm getting ready to put that one on my graph now. Good questions. And then I get into my negative exponents. What do negative exponents do? 1 over something. So 1 over what for 2 to the negative 1? Not 1 over 1. 1 over 2, yes. So I have an ordered pair at negative 1, 1/2. 2 to the negative 2 is going to give me 1 over something. 1 over 4. So 1/4. Notice none of my y's come out negative. My parent function, if you look at where these dots are, they're starting to level out and get very flat along that x-axis there. It's never going to cross the x-axis, so it lays flat across this x-axis, and then it curves through those points that we've just plotted. So here's the parent function. Then to do my transformed function, before I even graph this transformed function at all, I'm going to put this on my graph. Y equals negative 3. So I go to negative 3 on the y-axis, and I do a horizontal, a back and forth line. To get this transformed function, my a value, the thing that's going to do the stretch, we always multiply that to whatever our y's are. So we're going to multiply each of these by our y value of 3.
Can you give me a calculator, please?
Yep. There you go.
Thank you.
You're welcome. What did we say this h value was going to do to the graph? Left 4. Which axis goes left and right? X. So this is going to affect just my x's. We're going to add h to all of these x's, and that will shift it left 4. So I'm going to add negative 4. Remember, my h value is negative 4. We're adding negative 4 to each of these. That is the only thing that will affect my x's. So I use that to get my new x's. Yes, ma'am. Yep. What is negative 4 plus negative 2? Negative 6. What is negative 4 plus negative 1? Negative 5. What about negative 4 plus 0? Negative 4. Negative 4 plus 1. Negative 3. And negative 4 plus 2. Negative 2. That's my new x's. Notice these are all 4 to the left of the ones in blue.
Wait.
Yep.
For the y, don't you have to add something as well?
Yes, we do. We've talked about A. We've talked about H. Who have we not put up here yet?
K.
K. K does what to my graph? We said it's going down 3. I always add K to my y's because the y-axis is what goes up and down.
So you add a minus 3?
Yep, which is adding a minus 3 is the same thing as subtracting 3. So I'm going to put a minus 3 at the back of each of these. And then,
It's minus 3 because it's a minus.
yep, it's going down, so I'm subtracting. I put this in my calculator. When you put it in your calculator, if it gives you a fraction back, how do you make it tell you the decimal? Arrows right above the enter key. You're going to push those arrows that point to the left and to the right. Yep, now hit those arrows. There you go. What do you guys get when you put this first one in the calculator? 1/4 and then parentheses 3 and then minus 3. Negative 2.25. So I'm going to go and plot this point right here. Negative 6, negative 2.25. Right about here. What about when we put this next one in the calculator? 1/2, parentheses 3, and then minus 3.
Negative 1.5.
Negative 1.5. So I'm going to go plot this point right here. Negative 5, negative 1.5. Right about here on my graph. What about the next one? When I put this one in my calculator?
Last one. That one.
Yeah, the middle one.
You get 0.
0. So I go plot the point at negative 4, 0. Right here. What about this point right here? Right up from the bottom. What'd you say? 3. So I have a point at negative 3, 3. Right here. And when I put the very last one in my calculator, 9. So I have a point at negative 2, 9. Right here. This is why it's so important to get this horizontal asymptote on before you draw that graph. Because what do you know about the horizontal asymptote? We are never allowed to do what? Touch it or go over it. We're never allowed to cross it. So what do I do when I get close to it? Yeah, it's just going to kind of flatten out there. So it lays flat along that asymptote, and then it curves through these points that we've drawn. Before we look at the next problem, What questions do you guys have for me about this one?
If there's no A, so it's just one, you don't have to put vertical stretch or anything or vertical
Correct.
stretch.
It's not different from the parent, so you don't have to describe it. That's absolutely correct.
And if there's no negative, so it's not going to be reflected on the axis.
Correct. If your A value is 1, you don't have to describe it because it's not different from the parent. I want you guys to take about 3-4 minutes, do the next one on your own, and then we'll go through it together. And that's the last thing we're going to do for today. Take right about 3-4 minutes.
What? Needed. Maybe. I'm getting shoulder. I didn't count.
Finish drawing your graph. Yes, I want you to do the second one. I want you to do number 13 on your own now.
Whoa. This is the y-axis, right? This, put this on the y.
So these two, yeah, these are your x's, these are your y's.
So -6.
Yes, sir. Okay.
So far as I'm not entirely sure.
Yep.
I just need to know how to graph it.
Okay, so why don't you finish getting this graph on there first so that you can
Okay.
see that. And then I'll come help you with the other one. Anthony, do you need another copy of the review? Do you need another copy of the review? If you have one.
Oh, yeah.
Okay. Go ahead and pull it out for me. Yes, sir.
For the range, you said A goes right here.
No, that's not your A, that's your K.
So
So if you look what I have written in pink off to the side, if your A is positive, then it's going to be K to infinity.
okay.
And if your A is negative, then right here is going to be a negative infinity and K would go on this side.
So it can be like 3 to infinity, right?
It could be 3 to infinity, yeah. But is that your K value?
Oh no, it's -5 too.
Let me look at it closely. That's a +5 actually. You just drew over it when you were circling it.
Oh,
That's a plus, so that will be a positive there.
right here.
Yep. And that would be a +5 right there. There you go. And then maybe just mark that guy out so you don't get confused.
Thank you.
You're welcome. I'm coming. Give me just 1 second. I'm going to answer Lauren's question, then I'll be right there, Caitlin.
African baby.
I'm talking about those like. I'm talking about baby what?
That came out by complete accident. I was looking at something on the back.
Okay, so for this one, cause like it's like A is positive, and since there is no A, it would just be 1, and 1 is positive, so it just
Yep.
be K, which is 5, and then.
Yep. You got it. That's absolutely right.
Do you put 1 or nothing if there's no A?
If there's no A, when you do your table, I would multiply by 1.
Let's mix
Do I have to write it?
But you don't have to write anything there because your A value here is exactly the same as your A value here. And if it's the same as the parent, you don't have to describe it.
And if they smell good, we can do that.
All right. Help me walk through this one. Here's my parent function. What is the base on that parent function? 4. What's the base on the transformed function? Also 4. Is that different from the parent? No. Then I don't have to describe anything about that. If it's not different from the parent, I don't have to describe it. Looking at that transformation, I still want to identify A, H, and K. Where do we look for the A value? Is that my A value? No, that's my base. It doesn't have an A value. If you don't see it, it is 1. So right here is where I would see that A value, and it is 1. Go look at the parent. What's the A value on the parent? Yeah, there isn't one, so it's a 1 here also. So is our A value different in the transformation? No, then I don't have to describe anything. I only have to describe things that are different. What is our H value on that transformation? 3. Right here is where we look at H, only that is the opposite of H. So H is 3. What will that do to my graph if H is a positive 3? It goes right. It's going to move to the right 3. Which one takes us up and down? The K value. What's our K value? 5. Right here is K. Will it go up or will it go down? Up. Up how far? Up 5. Since I know my K value, what else do I know over here? The asymptote. What is our horizontal asymptote? Y equals 5. Don't forget the y equals part. Super important. It's always y equals k. What will the domain be? This is never changing for all of my exponential functions. All real numbers. And then I want to do the range.
Is it
5 to infinity. How do you know?
because the A is positive?
A is positive. In this case, our A was just a 1, but that's still positive. So it's going to be K, 5, to infinity. All right. Let's do our parent graph and then our transformation, and then we are done.
We have to graph our parent.
Yes.
We have to graph it on the test.
If it so like right here it says graph the parent. If the directions say graph the parent, it is worth points, and so you'll want to make sure to do it. If it doesn't say graph the parent, then you don't have to do that one. But it's usually going to say graph the parent. So I go with my 5 favorite x's. We get to pick those. These are my 5 favorites. Not only are they small, easy to work with numbers, but they also let me know what does the function look like when x is negative, what does the function look like when x is positive, and what's happening right at 0, because a lot of times something special can happen there and I want to know what's going on. How do I find the y's for the parent?
You put 4 in a substitute.
Yes. We're coming here to the parent. The base on the parent is 4.
Yeah.
And it's going to be to the power of whatever our x is right there. So 4.
So the y is always the base, like it's the base.
It's going to be the base of the parent, yes. What is 4 squared? 16. Is that point going to fit on my graph here? If the point doesn't fit on the graph, do I have to try to graph it? Nope. What is 4 to the first power? 4. Will this one fit on my graph? So I have a point at 1, 4, right here. What is 4 to the 0 power? 1. So I have a point at 0, 1. What is 4 to the negative first power? 1 over 4. So that's going to be right about here, very close to the x-axis. What is 4 to the negative 2? 1 over 16. Again, very, very close to the x-axis, but it's not negative, so I don't go underneath it. Lays flat along the x-axis until we get to these points that we've graphed, and it curves through these points. Here's my parent. I'm going to do it this way. Before I put the transformation on my graph, what should I put on there first? Before I graph the transformation, before I do the rest of my table.
Put the horizontal asymptote.
Yes, asymptote. We're going to put the horizontal asymptote. Where's it going to go? At the 5. So back and forth right here at 5 on the y-axis. My transformation is not going to be allowed to cross that. Yes, ma'am. Asymptote. Asymptote. Not taupe, it's asymptote. Like a tote bag. Asymptote. I wish I knew where that word came from. I have no idea. That is not one of the things that they taught me when I was learning how to be a math teacher. What did we say our A value was? 1. My y's are all going to get multiplied by 1. What happens when I multiply by 1? Nothing. That's why I did not have to describe anything in my transformation. Because nothing changed. Yes. What do I do with the h value of 3? What do I do with the h value of 3? Add it to x's. So I add 3 to each of these numbers. So my new x's are what? What's 3 plus negative 2? 1. What's 3 plus negative 1? 2. 3 plus 0? 3. 3 plus 1? 4. And 3 plus 2? 5. What have I left out? The k. What do I do with my k value? We add it after the y. What is our k value? 5. So I'm going to add 5 to each of these. And then I grab my calculator because I'm going to put this in my calculator. This is how I get my new y values. When I put this first one in the calculator, 1 over 16 times 1 plus 5, what do we get? 5.06 something, something, something. That's good enough for me to get a point on my graph. 5.06 is going to be barely above the 5. So right here. Shh, guys just finish up this last bit with me. What about when I put this next one in my calculator? 5.25. So I have a point at 2 and 5.25. Pretty close to the first point. What about this third one down? Six. I have a point at 3, 6. Right here. Next to last. 9. So I have a point at 4, 9. The last one's 21. Can I get that one on my graph? Nope. So I don't worry about it. Lays flat along that asymptote. We're not allowed to cross it. And it curves through these points. And that is my graph. You guys have the rest of the time to work on review problems, work on homework. Also, if you did not turn in your bell work yesterday, you want to make sure to turn that in today because I'm going to be putting that into Skyward. Anything else you need to work on to get ready for the test?